Welcome children to our next maths class. We'll be doing chapter 3, playing with numbers. So here I'll start with the divisibility test first, and then I'll move on to factors, multiples, HCF and LCM. So the divisibility test that I'll give you today, I expect you to write all this down in your classwork copy. Am I clear to everybody? So we have done some of them before also. So it should not be a problem for you. So let's start test for divisibility of numbers. Divisibility by 2. So when do you say a number is divisible by 2? If the digit in the ones place is even. That is 0, 2, 4, 6 or 8. Okay. Now here I have given you every divisibility test, 2 example sums for you to understand better. So here the first sum is 1956 divisible by 2. So here you have to write the answer. The solution should be done in the statement form. Now here I have highlighted the last digit 6, which is even. So I have written down the ones digit in 1956 is 6, that is even. So 1956 is divisible by 2. You have to not write anything else except these statements. Now suppose you have to find out whether this number 20,519 is divisible by 2. You have to check only the last digit. You can underline it, you can circle it, you can highlight it, it's up to you. Then you write the ones digit is 9, which is not an even number. So when the last digit is not even, the whole number is not even. So we write 20,519 is not divisible by 2. Next is divisibility by 3. A number is said to be divisible by 3 if the sum of the digits is divisible by 3. So for 3, it's a different one. You have to add all the digits and see whether that sum is divisible by 3. And if it is divisible by 3, it is also a multiple of 3, isn't it? It's the same thing. Suppose 3. 3 is divisible by 3 also. And also 3 is a multiple of 3. 3 ones are 3. Similarly, 6. It is divisible by 3. You can divide by 3 and without any remainder. So we also say 6 is a multiple of 3. So it's the same thing. So whichever way you want to write, it's up to you. Now with examples, it's 2,936 divisible by 3. So sum of the digits we find out 2936. So we add up this and we get 20. Now you can add up again 2 plus 0, which gives you 2. So if you add up and you write 2 plus 0, again sum is equal to 2 plus 0 is equal to 2. So you can write here 2 is not a multiple of 3. Or you can directly write 20 is not a multiple of 3. So therefore 2936 is not divisible by 3. So this is how you write down. Now suppose you have to find out 41,031 is divisible by 3 or not. So again you add up the digits. All the digits needs to be added up and you write sum of the digits. So when you add up you get 12. You can write sum again is equal to 1 plus 2 is equal to 3. If you want you write. Otherwise all of you know that 12 is a multiple of 3 or divisible by 3. So 12 is divisible by 3 or you can write 12 is a multiple of 3. So if the sum is divisible by 3 then the whole number which was given 41,031 is divisible by 3. Next we move on to 4, divisibility test of 4. Now here for 4, suppose for 2-digit number you have to divide and check. So it is applicable for 3-digit number or more. So a number with 3 or more digits will be divisible by 4 if the last 2 digits, the number formed by these last 2 digits is divisible by 4. So this is a question which is given 3 crores 17 lakhs 95,072 is divisible by 4. So what we do, we take the last digit. I have divided by 4. You can do it orally. It's up to you. There is no remainder. So the last 2 digits, that is 72, is divisible by 4. Therefore, the whole number, see how I've written. First you have to write 72 is divisible by 4. Then you have to write the whole number is divisible by 4. Another example. is this divisible by 4? 1238. So what I did, I took the last two digits, I divided by 4. You can do orally also. So we have a remainder. So since 38 is not exactly divisible by 4, so the whole number 1238 is not divisible by 4. So you have to learn. For 2, we have to check the last digit. For divisibility by 3, we are doing only the sum of the digits. For 4, we are checking the last digits. We are checking the last two digits. We are dividing by 4 and checking. So all these have different steps. So please write it down and go through properly. Divisibility by 5. So for 5, we have to check only the last digit. If it is 0 or 5, then it will be divisible by 5. Now here in this number, the last digit is 0. So we just have to write last digit is 0, so it is divisible by 5. Now is this divisible by 5? You have to write last digit is not 0 or 5. It is 6. Therefore, the whole number, this number is not divisible by 5. So see, only in 2 statements. So it is not very difficult. You just have to learn it, what to write. So last digit should be 0 or 5. Since last digit is 6, that's the ones place digit is 6. So the whole number, 285,136, is not divisible by 5. Now we have by 6. Now for 6 children, we have to show that the number is divisible by both 2 and 3. If it is not divisible by 2, but by 3, then we say it is not divisible by 6. But if the number is divisible by 3 and not by 2, then also it's not divisible by 6. So until and unless that number is divisible both by 2 and 3, then only it will be divisible by 6. So now there is a question here. This 9,01,352 is divisible by 6. So I have written like this, stepwise, by 2 first, okay? So I wrote by 2. So the last digit is 2, which is even. So it is divisible by 2. So can you see how I've checked for the first, this number, whether this number is divisible by 2. Then I will check whether this number is divisible by 3. So when I added up, I got 20, which is not divisible by 3. So this number is not divisible by 3. So then I write my final answer by 6, whether it is divisible by 6. So what do we infer? We conclude that the whole number is not divisible by 6. Now for the next one, is this divisible by 6? Now let's check. Now the last digit, first I wrote by 2. For 2, I have checked the last digit. It is 0, so it is divisible by 2. Now for 3, I've checked the sum of the digits. It's 27, which is also divisible by 3. So the number is divisible by 3. So here just 2 statements. Here there are just 3 statements. So finally by 6, we write that the whole number, we write again, is divisible by 6. Okay, that's 4,38,750 is divisible by 6. Next, we come to divisibility by 8. Now, since 7 is not included in your textbook, I've skipped that. Now, divisibility by 8. Now, in case of like 4, we had checked the last 2 digits. And the divisibility test was applicable for number with more than 2 digits. Here also for divisibility by 8, it is applicable for 4 and more digits. Because 3 digits, you have to divide and check. So you have to learn this. A number is divisible by 8 if the number formed by its digits in the last 3 places, that is hundreds, tens, and units, is divisible by 8. So for 8, suppose this is a question, 67,152, it's divisible by 8 or not. So we take 152 and we divide by 8. You can do orally also. Those are good in calculation. Otherwise, you can do like this. Since there's no remainder, so 152 is divisible by 8. So the whole number, 67,152, is divisible by 8. So for 8, you have to check the last 3 digits, divide by 8, and see whether it is exactly divisible or not. Now here is another example I've given you is 9,364 divisible by 8. So here we take the last three digits, 364. So when I divided by 8, I got this. So 364, the last three digits is not divisible by 8. So 9,364 is not divisible by 8. Now for divisibility by 9, it is same as divisibility by 3. Here also we have to check the sum of the digits. So you have to learn all this and then you do this example whether 9,01,153 is divisible by 9. So you have to find the sum of the digits, which is 19. The 19 is not divisible by 9. So the whole number is not divisible by 9. So you write the number down. So the same as 3. For 3 also we found the sum and we saw whether it is a multiple of 3. Here also we have to see whether the sum of the digits is a multiple of 9 or not. So here it is not divisible by 9. But for this, when we add up these digits, the second question, sum of the digits, we add up 1 plus 0 plus 8 plus 3 plus 6, that's 18. So since 18 is divisible by 9, then the whole number is divisible by 9. That is 10,836 is divisible by 9. So I hope that's clear till now. Now we move on to 10. Divisibility by 10. It is also very easy. For 10, we have to check the last digit. Now, you know all the multiples of 10 end in 0, isn't it? At least 1 0 in the units place. So how can you write? If the digit in the ones place of a number is 0, then the number is said to be divisible by 10. So for this number, whether it's divisible by 10, the last digit should be 0. So here it is, the last digit is 6 and not 0. So therefore, 71,056 is not divisible by 10. Now for this second question, the last digit is 0. So this is a number which is a multiple of 10. Hence, you have, this is divisible by 10. Okay. 84,30,250 is divisible by 10. For divisibility by 11, now this is new to you, so please see what I've written here. Now I have not given you the definition in one line, I've just written in steps. We find the sum of the digits at odd places from right. Next we find sum of the digits at even places from right. Then we find their difference.
If the difference is either 0 or a multiple of 11, then the number is said to be divisible by 11.
So now I've done a sum for you. Is 7 crores 1,69,308 divisible by 11. So what I did here, now these were the things we needed to find out. Sum of the odd place digits from right. So this is your right. So what I did, I wrote down 1, 2, 3, 4, 5, 6 like this till here to see which are the odd places and which are the even places from the right. So this is the odd place, the first odd place from the right. Then this 6, fifth place is 6, seventh place is 0. So these are the odd places from the right. So this digit I'll take 8, isn't it? I've taken 8. Then the third place is 3. Then comes 6, fifth place. Then comes 0, the seventh place. So I added up, I got 17. Now I found out the sum of the even place digit from right. So from that right, this is the even place, second place. Fourth place digit is 9. Sixth place digit is 1. 8th place digit is 7. These are the places. So I take 0, 9, 1 and 7 here and I add up. So what do I get? 17. So difference is 17 minus 17, I get 0. So it is divisible by 11. Hence, the whole thing, since it is 0, the whole number is divisible by 11. Now for the next one, 71,381, it is divisible by 11 or not. So here also I wrote down the places. These are the places. First place from the right, second place, third place, fourth place, fifth place. So I took the odd places. I have highlighted it. You can circle it or highlight it. Then 1 plus 3 plus 7. I got 11. 2 plus 1. Second place is, 8 plus. Fourth place is 1. So 8 plus 1 is 9. These are the some of the even places from right. So the difference is what? 11 minus 9, which is 2. So since difference is neither 0 nor multiple of 11, it should be divisible by 11, okay? So we got answer 2, which is not a multiple of 11. So therefore 71,381 is not divisible by 11, okay? So in your definition, please write down that it should be 0 or multiple of 11, okay? Now here, all this which I have given here, please do it in your classwork copy. And for exercise from this exercise 3.3, do number 5 and 6. Try this out. You write the question as well as the solution. You try it out, use these divisibility tests and find out. We can discuss it later on. We'll get back to the solutions later on.